Okay, we're looking at problem 42 from chapter 6 on page 320 of your textbook, problem number 42. And this is going to be dealing with some conditional probability and how it affects independence. Now, the first thing it wants you to do in part A of this problem is it just wants you to interpret what the probability of R given D is. So it's going to ask us to interpret this probability. So this probability basically means I have a 30% chance from the 0.30 of R occurring, which in this case is a rollover. So R is a rollover occurring, given that the accident occurs in death. So given that a death occurs in this accident. So that is how you would interpret that. For part B, it's going to want you to interpret the probability of F given D. So this probability here of F given D is what we're going to be interpreting in this part. And that's going to be that you have a 54% probability of a frontal collision given that a death occurs. Okay, now the next thing it wants to know is if the events R and D are independent. The easiest way to find out if events are independent is by comparing some similar probabilities. So the two probabilities I want to look at here is the probability of a rollover, which is up here, and the probability of a rollover given that there is a death. Now, what I can tell by looking at these two probabilities is this top probability here says the probability of a rollover is only about 6% of accidents are rollovers. On this one, the probability of a rollover, given that there's a death occur, says that there's 30% of fatal accidents involve a rollover. Therefore, I would say that these events are not independent, because to be independent, the probability of R would have to be equal to the probability of R given D. So in this case, they are not independent because these are not equal. So anytime these two events are not equal, adding the conditional or given information makes the probabilities not equal. That means they are not independent. Okay, the next thing it wants me to test is it wants me to test to see if I can just multiply these probabilities. So if I do, it wants to know if F and D is equal to the probability of F and the probability of D. Now, the first thing you might think is we have no idea the probability of D. And while that is true, I can show you by how to figure this out, because if I look at these two probabilities, the probability of F and F given D, I can tell that these are not independent events, because once again these two probabilities are not equal. So since F and D are not independent, that's going to mean that you cannot just multiply. So since F and D are not independent, that means you could not just multiply the probability of F times the probability of D to get that probability they're asking for. So it's not going to be equal to the probability of F and D. The last piece it's wanting to know is it's wanting to know if the probability of if a frontal collision is equal to being the complement of a rollover. That means not a rollover. Well, now these, if these were complementary events, they would have to be equal. So and I do not believe that these are going to be complementary events, because the probability of a frontal collision is 0.6, and the probability of it not being a rollover is 1 minus 0.6. So that means these are not complementary probabilities because those two expressions are not equal to each other. 60% is definitely not equal to 94%. Also, it just makes common sense to consider that there's other types of accidents other than just frontal collisions and rollovers, and if things are complementary events, that means any time that it was not a rollover, it would have to be a frontal collision.